Hello, this is Kedulytics and welcome to today's session. In today's video, we are going to look at odds ratio and risk ratio. And we'll also be able to know which kind of study design will warrant the use of which, and how we can use the STATA platform to run and attempt to interpret the results. So without wasting much time, we type to see what our data set looks like. So this is what CVD, cardiovascular disease, 1 coded as 1 and 0, where 1 would be a case and 0 as control for a case control study. And 1 will be a case and 0 will be a non-case for a cohort study or a longitudinal study. Now, our exposure variable, 1 is exposed and then 0 is unexposed. That's family history of CVD. So those who have family history are exposed and those that don't have are unexposed. Now, having that background about our data sets, we now want to see first running the odds ratio for a case control study. So the code we need to be able to get our odds ratio in STATA is CC, and then our outcome, and then exposure. So we type, click on enter, and then we have our result here displayed. So here we have exposed, unexposed, cases and control. It is cases and control because this is a case control study. So we set out to perform a case control study, and at the end of the day, we generated the data sets. And so when we want to look at the association strength, we look at odds ratio. So now the odds ratio here is 1.679074, meaning that there's a 68%, about 68% increase odds of having CVD among the exposed compared to the unexposed. And then the attributable fraction and the attributable fraction population, we'll explain it more when we get to the case control. So let's move on to that one, and after that we'll explain. So to run the same association, by this time the study design is a cohort study, we'll change this from CC to CS so we can be able to get risk ratio instead of odds ratio. So this gives us risk ratio instead of odds ratio. Now, the risk ratio here is 1.23 that. So what it means is that there's a 23% increased risk of getting CVD among the exposed compared to unexposed. Now, the risk difference at the top here is positive, meaning that there is more risk among the exposed compared to the unexposed. Had it been negative, then it would mean that there is more risk among the unexposed compared to the exposed. Now, the attributable fraction exposed means that this amount of risk would be avoided by the exposed if they were unexposed. And the attributable fraction population is that this amount of risk would be avoided among the population of the cases if they were unexposed. This is an attempted explanation and you will find it useful. We encourage you to subscribe to the channel if you like content such as this. Like and share. Until we meet again, this is Kedulytics and it's a bye.